Welcome back from fall break, guys. Today we are doing lines, angles, and planes. We're starting chapter 3. The objective today is to identify parallel lines, skew lines, and parallel planes in three-dimensional figures, identify perpendicular lines from a figure, and identify the angles formed when two lines are cut by a transversal. So we'll do a couple definitions here first. So parallel lines are lines that are coplanar and they do not intersect. So a couple examples here. Oh, and this symbol here is parallel too. So you will see us use that quite a bit. So looking at the diagram, some examples would be AE is parallel to BF. So those are written with those green lines there, or they're highlighted with the green. And also line AD is parallel to BC, and you can see that by the green lines as well. Make sure you write this part down here. Whoops, don't want to do that. Make sure you write this down, because you guys will be using that sometime. Use arrows to show that AE is parallel to BF and AD is parallel to BC. So we use these little arrows here to say that these two are parallel, and then we use a double arrow to say that these two are parallel. Okay, skew lines. Whoops. Oh no. Sorry, guys. Skew lines are non-coplanar, and they are not parallel and do not intersect. So this was probably a little bit harder for you guys on the intro, but some examples would be AB and CG are skew, and those are shown by the green highlights there. They have to be not in the same plane and not parallel, okay? So they cannot be, so say we have this guy here, this is one plane, and then this is another. They cannot be in the same plane. So if you notice, these two overlap here, right here. So we cannot choose that, and then, you know, a corresponding line in the same plane. Those would not be skew. Let's think about this. Are AD and FG parallel or skew? Look at those two lines there. They're shown by the green right here and right here. Are they parallel or skew? These are parallel because we could technically draw a plane between them. There's not one in the actual diagram, but they are parallel because we could draw a plane between them. Parallel planes are planes that do not intersect. So plane A, B, C, D, and plane E, F, G, H would be an example. Okay. Then the next definition that we want to know is perpendicular. Perpendicular are two lines that intersect to form a right angle. So we have, if we are doing a symbol of this, you guys will see this a lot. The symbol for perpendicular is like an upside down T, okay? So it looks like that. So for example, if we have this, we would say that line AB is perpendicular to line CD because they form a right angle, okay? And for it to be a right angle, it has to have that little square in the corner. So go ahead and identify the following pictures. You can pause it using your definitions from above. So the first one would be skew lines because they're not intersecting, they're not in the same plane. The next one would be parallel lines. We know that because we have this little arrow there. The next one would be parallel planes. They're obviously not intersecting and they are going in the same directions. And then the last one would be perpendicular lines because we have that little square there to show that those two intersect in a right angle. So go ahead and try these next 4 questions. Pause your video and then wait, or actually do your questions and then play the video so that you can get the answers. Use the figure to the right to do these questions. So I'm going to go ahead and explain. Which segments are parallel to AB? So we have AB right here. So there are a lot of different options. You could say EF. Those would be parallel. You could say DC, or you could say HG. And it doesn't matter what order you put those in, just as long as you have the 2 letters to show that that's your line segment, your points on that line segment. Okay, which segments are skew to CD? So we have CD right here. Okay, skew would mean they can't be in the same plane, and they also cannot be parallel. So looking at these, I would have this one would not be in the same plane. This one would not be in the same plane. This one would not be in the same plane. And this one down below here would not be in the same plane. So you'd have BF, AE, EH, and FG. Okay, what are 2 pairs of parallel planes? So we could say the top guy, this one, and the bottom one. Or we could have the 2 side ones, this one and this one. So plane ABCD is parallel to EFGH, or plane DCG, which is your side one in yellow here, is parallel to this one. And you could also do, some more here. What are 2 segments parallel to plane BCGF? So first of all, BCGF is this one back here. Okay, I think this is the hardest part for you guys is to decipher where that plane is. So 2 segments that are parallel to that plane. So we could say that AD is parallel. EH could be parallel. Let's see, what else could be parallel to that plane? Because the plane could be, the whole plane, we could have these 2 segments as well. So AD, DH, HE, and AE. Okay, which of the lines in the diagram fit the description? So parallel to PQ and contains S. So you have to think about, all right, so here is PQ, but it has to have the letter S in it. So obviously, if we are doing a parallel line, it has to not intersect it. And here is where S is, so which one would be parallel? It would be ST. So then we have the same thing, perpendicular, actually not the same thing, but the same concept. So we have PQ, it contains S, and it's perpendicular. So perpendicular means it intersects at a right angle. S would be here. How would we get that to intersect in a right angle? They obviously, because it's perpendicular, they have to intersect. So I would say this one, because we know that, okay, if 2 lines, we could just assume that that would be perpendicular because we are drawing that line in. Skew, so we have PQ, skew, and contains S. So it cannot be going in the same direction. It obviously cannot intersect it because if your lines are intersecting, then they're coplanar. So here's S, and I would say you could do SU here, because those 2 are not going to intersect. Oh, whoops. Sorry, guys. SU would be your answer. Name the plane that contains S and appears to be parallel to plane PQR. So here is PQR. So parallel plane would be this one behind. It contains S. So it's plane SUT or STU, however you want to put it. Okay, go ahead and try these next ones. So you have the two, you have the ones that are parallel and skew with this triangular prism, and then you have parallel and skew to the for the rectangular prism. So go ahead and pause your video and try those questions out. Okay, so for BC, parallel to BC, obviously you can have different answers, but BC is right here. So we could have line EF, whoops, I do not want that color, line EF, wonder if I wrote these down, right here, and that's pretty much it because, okay, I do have the answers, sweet, because there are no other lines that would be parallel to this. The other ones would all intersect or it would be skewed to it. For FC, so FC is over here. So then parallel lines, you could actually have two answers for this. You could do EB or you could do DA. This one or this one. Then for DF, so DF is up here. A parallel line to that one, the only option would be AC. Okay. Name a line skew to BC. So we have BC here. Skew would be something that doesn't intersect it and is not parallel. So we could do DA over here. Let's see what pops up. We could also say DE, and we could also say DF. All three of those would work. So do DA as well, because those two would be skew, or all three of those would be skew. Okay, for FC, right here, so we are doing a skew line to that. So it cannot be in the same plane, and it cannot be parallel. So we could do, let's see what we have first. We have DE and we have AB. Those two would work. Lost my train of thought here. If I did choose DA, yeah, it's not in the same plane, but those two are parallel, so that would not work. And I guess, let's see, D, B, C, yeah, okay. Then we have DF. So DF is here. Skew lines for DF would be AB and BC. You cannot do AC because that one would be parallel. You could, if you wanted to, do EB, that would work. That's not parallel. Okay, then go on to your next ones. Try these. Name a line parallel to BC, line BC. So we'd have AH, here's BC. We would have AH, we'd have FG, we'd have ED, and that is all of your options for that one. Parallel to GH, so GH is here, so we could do DC, we could do EB, we could do FA. Those would all be parallel. Then we have HC, so HC is here, so again you'd have three options there. You could do AB, you could do FE, you could do GD. Name a line skew to BC. So here's BC. Skew would be something that doesn't intersect it. Okay, so we could do FE, which would be here. DG, which would be here. FA, which would be here, they're never going to intersect, and GH, which would be there. Then we have line segment GH. So line segment GH is here, whoops. So your answers for that one could be FE, ED, AB, and BC. And then for HC, which would be this one here, you would have FA, FG, ED, or EB here. All right, so transversals. A transversal is a line that intersects or crosses two or more other lines. So you can see you have your two lines that are not parallel, and then you have the transversal that cuts through it. Some vocab here is interior and exterior. Interior is the inside, exterior is the outside. Alternate sides of the transversal, you have the left side and the right side of the transversal. So angles cut by a transversal. Now on your notes, you don't have to write anything down, but just look at the portion that has the boxes on it, because that will help you kind of put a figure to the notes there. So alternate interior angles, an example would be 3 and 6. They are on alternate sides of the transversal, but they are inside the two lines. Alternate exterior angles are on opposite sides of the transversal, but they are exterior or outside of those two lines. So 2 and 7 would be an example. Same side interior. Now interior means inside, same side, obviously it's going to be on the left or the right side of a transversal. So you can do 4 and 6, or 3 and 5 would also work. Same side exterior, so that's on the outside, but it has to be on either the left or the right. So an example would be either 2 and 8, or you could do 1 and 7. And then corresponding angles are the ones that I think you guys get the most confused on, but corresponding angles has to be on the same side of the transversal, so either the left or the right hand side. And then they have to be, one has to be in the interior, one has to be in the exterior. So an example would be 2 and 6. 2 is outside of those lines, 6 is inside of those lines. 5 and 6 are not considered alternate interior angles, but why? So we know that alternate interior angles would be 3 and 6. Whoops. Why 3 and 6? So 5 and 6 are not alternate interior because they share a vertex rather. Alternate interior angles do not share a vertex, and that's something that you definitely want to write down on your notes. Okay, so then go ahead and do 1 through 10 and answer the questions, and then check your answers with mine. So number 1 is a same side interior because they are inside the two lines and they are on the same side. Number 2 are alternate interior. They are on opposite sides of that transversal and they are on the outside of the two lines. Number 3 is an alternate interior pair because they are on opposite sides of the transversal and they are inside those two lines. Number 4 is corresponding. They are on the same side, but one is interior, one is exterior. Number 5 is same side interior. They are on the same side, they're inside those two lines. Number 6 would be alternate exterior. Number 7 is corresponding. Notice how these two, we have one that's exterior, one that's interior. This one's interior, then this one's exterior. They can look different for corresponding angles. Number 8 is an alternate interior pair. They're on opposite sides of the transversal. They're on the inside of the two lines. And number 10, we're coming at you with an old vocab word here, but these are always vertical angles. As long as they share a vertex and they are across from each other like these two are, they are called vertical angles. Angle 9 and angle 11. Those are alternate interior angles. Angle 6 and angle 10 are on the same side. Angle 6 is exterior, angle 10 is interior, so this would be a corresponding angle. Angle 8 and angle 11, those guys are on the same side, so it would be same side interior. And then angle 7 and angle 13 are exterior angles, and they are, oh my gosh, I just lost, alternate. They're on opposite sides of the transversal, so alternate exterior angles. Use a diagram to the right to answer the following question. So we're looking for all 4 pairs of corresponding angles. That means you need to list 8 angles. So we would have angle 1 and angle 7, angle 2 and angle 4, angle 8 and angle 6, and then angle 3 and angle 5. So they have to be on the same side, but one has to be interior, which is 3. 5 is the exterior angle. Name both pairs of alternate interior angles. So we'd have angle 7 and angle 3, or angle 8 and angle 4. Exterior, alternate exterior angles would be the same concept except they're outside. So we'd have 1 and 5, or 2 and, 1 and 5, or 2 and 6. Same side interior, obviously they have to be on the same side and on the inside, so 8 and 7, and then 3 and 4. So flip over to the back page, transversals with multiple lines. Basically, when we have multiple lines, we have to think of each set of lines separately. So if we are doing identify all angles that are alternate interiors with angle 3. Okay, so we are basically going to kind of like, okay, let's scratch this bottom one off and not use that one for this first thing. So alternate interior with angle 3 for the first line would be angle 3 and angle 6. So angle 6 is one of the alternate interior angles with angle 3. Then we want to think about, okay, now we're going to scratch this guy off here and only deal with the bottom part. So alternate interior, we're not using this. Inside would be 3 and 10. Would be alternate interior angles. Okay, now we are going to try identify all angles that are corresponding with angle 5. Okay, so first one, we want to not deal with the bottom one. So between the top 2 lines, which one's corresponding? It would be angle 1, because they have to be on the same side, but one has to be interior, which would be angle 5, one has to be exterior, which would be angle 1. Then we don't deal with the top line, we deal with the bottom 2 lines. So now corresponding, this one, angle 5, is now exterior, so I need an interior one on the same side. It can't be 7, can't be 11, it has to be 9. So go ahead and do your homework on the back. It's only 12 questions. The one that I really want you to focus on here is number 12 here. Okay, so do your homework and then you can either come back to here or just listen. So angle 6 is here. If we were to cross this out up here, right, my corresponding angle would be angle 4. Now, because it's multiple lines, I need to deal with both. So now if I cross this out, right, I do not have a corresponding angle with angle 6 here because this one is interior and so are the rest of these. These are all interior. So for 6 to have a corresponding angle, it would have to be up here, but we don't have a number there. So The only angle that would correspond with angle 6 is 4. Go ahead and start the next video. Make sure that you take a picture of just the back side of your chapter 3 note or 3.1 notes so that you can get points for your homework. I know it's only 12 questions, but make sure you take a picture of just that page.